I would like to welcome everybody and in respect with everybody and their profession. Thank you for attending this session. I'm Kamoga Ronald. I'm going to be taking you through today. And with us today, we are very humbled to have something to talk about, that's embedding classification in construction projects by Dr. Noha Saleeb from, she's an associate professor at the Construction and Creative Technology, that is Middlesex University in the UK. She's going to first present, then we shall have a Q&A session at the end. So just to make it clear, you can just type your question in the Q&A, and then I will be asking her, and then she will respond to the questions. Without further ado, we would like to welcome our facilitator for today, Dr. Noha Saleeb, for the presentation today. Thank you so much.
Thank you very much for the introduction, and good afternoon, good evening, or maybe even good morning to everybody. I'm very pleased to be with everybody today. As my colleague said, I'm an associate professor in construction digital technologies at Middlesex University in UK. I'm also program leader for the Masters in BIM Management and Integrated Digital Delivery there. And I'm very pleased to be part of the BIM Africa organizing team as well. And I'm originally from Egypt in Africa as well. So I have been consulting and working as an architect for many years before I even went into academia. And one of the topics which I thought would be interesting to talk about is something that is sometimes omitted or not presented well, not used well in many projects globally. And that is the topic of classification. So what seems to be a very dry subject, I'm hoping to bring more light and brightness to it and show how we can do that and why we need to do that. I'm hoping also towards the end to present a project of mine that I've been working on as part of an international project that is related to classification and heritage as well. So I'll try to move on. I'll be aware of the time so that we can have enough time for discussion at the end. So I'm going to start talking about what classification is, why we need it, how we might embed it in our projects, and also the difference between the word classification and measurement, because there are many classification systems out there that are confused with what we call measurement systems. So I'm going to try to show a difference between them. So one of the measurement systems is called NRM, and I'm going to talk a little bit towards the end about how that is related to cost. Okay, so without further ado, so when we talk about components in the construction industry, so something like what we have in front of me here, I hope you can see my mouse. I'll try just to be a little bit interactive with you. So you have a few types of walls, which is a component of every asset that we have in the built industry. So you can have masonry walls, concrete walls, you can have timber walls, metal walls, glass walls. So if we are to think, are these walls independent or are they part of a higher level of system or component? Usually I'd like to have this as a discussion, an interactive discussion, but of course, because of my awareness of the time, I'm going to ask the questions and answer them myself, basically. So when I think of something like that, I realize that these are part of something that is bigger than themselves. So both concrete and masonry walls, for example, can be considered as structural walls. Sometimes they can even be bearing walls. The other walls, which are glass or metal, well, not metal, metal can also be sometimes structural, but I mean, usually these walls at the bottom are non-structural walls per se, but they're all part of an envelope. So they are created as part of an envelope. So we start seeing that a hierarchy starts coming into place We have the lower level components, and those low level components are part of another higher level system. It doesn't stop there. These two high level systems are part of an even higher level system, which we can talk about as being single walls, for example. So maybe composite walls would contain other kinds of walls, that we don't have in front of us here. And both single and composite walls are part of walls in general. So if we talk about classification of walls, then we need to discuss the hierarchy of what they belong to. If you think about it, the family that they belong to. And so does everything else in the construction industry. Nothing exists on its own. Everything is part of a higher level system that it belongs to. This is why it is important for us to classify or specify or codify. I mean, these are all names that mean almost the same thing of what we're actually dealing with. Let me give you another example. Okay, so I think we are all familiar with these objects in front of us. These are all families inside of a software like Revit, for example. And of course, I'm aware that many people here might not be using this software per se, but this is just an example. So you can see in front of you here, plug valves, so different plug valves. Okay, there are several of them. There are different butterfly valves here. And whilst the name is the same, okay, so pump dosing here, I'm not a mechanical engineer per se, but I'm just giving an example. So you have many objects here which have the same naming, but they are actually different. They are different usages. They belong to different systems, even though the name is the same. And they are used for different things. They can be used inside different rooms for different functions. So how do we differentiate between them when we come to put them inside our graphical models and inside our non-graphical databases or tables and spreadsheets and documents? Well, the only way to do this is to give an individual code or classification to each one of them that would be unique to that one specifically, so that when we come to order it later on, procure it, maintain it, we know exactly what we're talking about. We're not going to go and say, please, we want to order 10 pieces of the plug valve that looks circular and has a 10 centimeter diameter, as opposed to the one that only has 2 centimeters, for example. We're not ever going to do that. So how do we go about creating a classification system that will allow us to do that? All right. So what you see in front of you is the focus on the actual product itself. But the product does not exist on its own. As I mentioned, the product could be part of a system. It could be part of a hot water system. It could be a drainage system, an HVAC system. Furthermore, that system could be part of a space. So maybe it's part of a control room. It's part of a ventilation room, of an exhaust room, whatever. And that space could have a certain activity. So even though there is a certain control room, within that control room, there are several activities that are taking place. So maybe that valve could be part of a wastewater treatment activity, but another valve could be part of a drainage, for example, or exhaust purification or whatever, okay? If we go even higher, that activity could exist within a certain building, or the north wing of this hospital, or the south rooms of this hotel, or this complex, or whatever. And furthermore, we need to know what is the overall complex that all of this exists within. Is it an airport terminal? Is it a hospital building? Is it an office building? So it is very important for us not just to identify what the product is and its code or its classification, but how it relates to that upper hierarchy of what it is part of as well, because that will influence what is the kind of product that we procure in the end and how we manage it, how we deal it on the long run. For example, this kind of product might be replaced sooner if this is part of a hospital complex, as opposed to it being part of a normal office building, for example, because, well, due to the criticality of its usage, for example. So the classification code does not exist on its own for the product. It needs to also be married with or seen in combination with the classifications of all of these higher hierarchy in which it exists. Okay, so this is just sort of like an introduction of why we need something called a classification, why is it a hierarchy, and why it could be important. Now, let's look at actual benefits that we need a classification for in the construction industry. Now, I've mentioned a few as I've been talking about right now, but I'll just try to give you 5 of the very important benefits which I see for classification. First of all, it's important that all of the teams and the stakeholders on a particular project have the same codes, the same specifications that they are working according to. So if you have, for example, a multinational team, one in the US, one in the UK, one in Africa, so on and so forth, how do they name or specify the objects, the systems that they are working with in the federated models between them and the federated non-graphical databases that they exchange with each other? We cannot give a name for a particular component, whether it be a chair or a table or a door or a valve. We cannot have different codes for it between different teams. So the first thing we need a classification for is to align all of the stakeholders' specification names, okay, or codification names. The second thing is to be aligned in that code system with the manufacturers. In the end, we are going to buy these products or create those systems by procuring those components from manufacturers. And like the first point here, those manufacturers could be local or they could be international. So again, we need to know what kind of codes those manufacturers use, and it would be good to align with them so that when we come to procure, it is easier to do that. I'm sure that many of you have heard, of course, of product data sheets and templates, which are being circulated or used nowadays. And these are basically documents that the manufacturer produces that explains all of the characteristics of a particular product or component, let's say a door or a window, but at the same time, part of that product's data sheet or template, you would find a classification code, which we will talk about in later on. How does that come about? How do we get it and things like that? But this is the second benefit. The third benefit is on transfer after construction on when you hand over to the maintenance, FM, facilities management and operations management, FM and OM teams. Those people also need to have certain codes, classifications, specifications for each component that they are maintaining or refurbishing or renovating. And of course, as you understand, this is really important because if they need to replace anything, they need to know how to do it and who to ask to get that. So there has to be also manuals that are produced and given at handover stage that have lists of these codes of all of these components or systems, or even the spaces and their usages. The fourth one is for heritage buildings. So similar to what I've just said in the previous three benefits, these three benefits are important in new builds, new buildings, but they are specifically also important when you have a database of objects that dates back hundreds of years and maybe even thousands of years. And I'm talking here about even my own Egyptian heritage of components. What if you want to replace an architrave, for example, of a certain column? How do you go about doing that? You need to have all of its characteristics and have international databases with international codes for similar objects, because these objects could be different from one architectural era to another. So maybe the architrave of an Ionic or a Doric column head could have different geometry between different centuries. So you need, for example, to have different codes for these in order to ask for replacement or even to ask for renovation. And the last one, which I have here as a benefit, is legacy data. So it never hurts to have a library of all of these codes that you have used on previous projects to use in new repeat projects. So if you have something like the NHS, the National Health System here in the UK, who produce hundreds of hospitals year in and year out, if this is repeated, then it doesn't hurt to have these libraries existing that can be used from one project to another. Or maybe the network rail, where they produce hundreds of rail stations and tube stations. So let's go on from here, and please feel free to put in your questions. I would be more than happy to answer them at the end. I wish it was possible to answer them as we go on, but I'll make sure to answer everything. So just a quick introduction about what are the existing classifications that we have in the world. So I'm just going to take you through a little bit of a history trip, show you a few that have emerged over the years and their differences. Well, just a little bit about their differences. So the first one which I want to introduce here is the CISFB classification system. And I don't even dare to pronounce the full name in Swedish, not to embarrass myself. But this system was created in 1959 by the Swedish Committee for Building Investigation, as you can see here. And it is one of the basis of the BS 1192 Part 5, which we have here in the UK. And it was basically a library classification for different objects. However, according to the users at the time, it was lacking in terms of specs. So other systems began to appear, like this one here, for example, the COS, the Common Arrangement of Work Sections. This was created by the CPIC organization in 1987, and it has more than 300 sections. It was aligned later on with a classification system that we use nowadays called Uniclass, so it was the basis of Uniclass. However, again, for that one, there were a few problems related to the ordering of the elements, and so it was not really seen as appropriate to use within computer models and 3D models. So moving on, there is one now that we use, which is called SFG20, the Standard Maintenance Specification. And this one is used a lot, specifically by manufacturers here in the UK, for example. It is one of the classification systems out there. It is a useful one and a successful one. And I will show you others in a minute. Our only problem is that because this one is used more in the facilities management and construction phase, not many architects and structural or MEP designers, maybe MEP designers, but architecture and structural do not necessarily use it during the design phases. So it is usually a little bit of a work when you move from the design phases onto construction facilities management to change between one classification system and another. But I mean, of course, this is something that has to be negotiated at the beginning of a project, and that's why we have BIM nowadays. One of the things that is in the power of a client is to define right from the start the classification systems that are to be used throughout the life cycle of a project, or at least stipulate in the EIR, or the exchange information requirements of the client, that this is to be negotiated and decided on by all of the stakeholders at the BEP stage, writing of the BIM execution plan, so that we would know exactly what systems are going to be used for classification, and if more than one, when the handover is going to happen, and that should be a deliverable in its own right, and how it will be done. And I have a slide later about how we can do something like that. Okay, so not to keep you much longer on this one, this was created in 1990 by the Building and Engineering Services Association. It has more than 400 schedules, and it is currently being used. The next two classification systems that I'm going to show you are the most popular and most used nowadays. So there's the Uniclass system. That is an American system. It was created in 2001 in the US by the National BIM Standard Organization, the NBIMS organization, which is an initiative of Building Smart, if you've heard of it. And it contains mainly 15 tables that are built according to the ISO standard 12006 part 2. You will notice that Omniclass and the next one I'm going to talk about, Uniclass, were created using that standard. And it has a few problems, even though it is still used to this day in the US, and it is being defined and redefined and improved almost yearly. There have been a few problems identified over the years, which are becoming resolved as we move along. So first of all, not all the tables deal with all disciplines, like architecture and civil and services and so on and so forth. Another thing is that, as I'm going to show you, and as I indicated at the beginning, a table of classification needs to contain a hierarchy, as we saw before. So like a masonry wall belongs to a maybe structural wall, belongs to a single wall, belongs to a wall, okay? It's not that simple, of course, but within those tables, some tables contain only 2 levels of hierarchy, whilst others go on to 8 levels of depth of hierarchy. And that has been seen as a little bit of an inconsistency, and sometimes causes problems when you come to write these classifications inside tables. Because when you come to verify to see whether things have been written correctly, it's sometimes difficult when you have a classification system that is smaller than others or written in a different way. Think of it like your telephone number. If you have different telephone numbers in the same country, some of them are 10 digits and some of them are 7, some of them are 8, it's going to be chaos and it's going to be very difficult to manage them. Okay, and lastly, the objects written inside those tables, some of them are referred to as individual objects and some of them as groups. So again, that could be a little bit of an inconsistency. So what else? The next one I want to show you is Uniclass, which was the one created in the UK. Now, unlike what people think, the first Uniclass iteration was created before Omniclass. So Omniclass was 2001. The first Uniclass was 1997. And it contained all of the faults of Omniclass, which I am showing you. So the scope, the levels, the objects, individual and groups. But in addition to that, there were 2 other things. There was absolutely no relationship or alignment between the tables and each other. And the codes themselves, which were used for each object, some of them were written in numbers, and some of them were written in numbers and letters, so alphanumerical. So next came the next iteration of Uniclass, which was Uniclass 2. Unfortunately, this was cut short before it was finished when the Uniclass project was handed over to the National British Standard Organization here in the UK, the MBS. And upon that, the Uniclass 2015 was created. And that is the one that we are using to date as being the most popular classification system that we're using in the UK and also adopted abroad in many, many countries. If I was to say what are the most used classification systems or popular, they're not the only ones, of course. I would say the Uniclass 2015 and the Omniclass. SFG, as I said before, is also used. Now, just a quick thing about Uniclass 2015. It's called 2015 because it was first created then with the tables that you see in front of you, almost 15 tables. The ones in red are the new ones. I'm going to talk in detail about them. And there are relationships. These are the relationships between those tables, which I will again explain in a minute. It has been improved and developed over the years, but because the structure is the same, it still keeps the 2015 nomenclature for it. And I am currently working with the MBS team who create the Uniclass 2015 to improve, to add components to it that are related to heritage as well. And we are even having a pilot study on the Westminster Palace here in the UK regarding that. So to go back to Uniclass 2015, why do we need to have a relationship between the tables? Simply because they are connected to each other. So one of the tables is called complexes. And complexes, like for example, an airport, a complete airport terminal, all right? And inside it, there are many spaces, okay? And inside the spaces, there are many activities, okay? Which contain many entities and systems, which within them contain many elements and many products, okay? Now, let me explain what these are, but before I do, I want to draw your attention to a few very strange tables that are part of the classification, but actually are very useful. So there is a table that is called tools and equipment, and these are related to temporary construction tools and equipment, not permanent building assets and permanent building products. There is also a table called CAD, and that is related to non-tangible things inside 3D geometry. And again, I'll show you examples. There's also a table called project management. So as you can imagine, these are also non-tangible requirements in project management. There's a table called forms of information and another one called roles. So even the roles and responsibilities has a table. So these last 5 tables do not actually relate to touchable, tangible objects in a building. So if I give you a bit of an idea, so complexes, for example, like a university campus or a rail network or wastewater treatment plant. If you go down to the table of the entities, you will find that it talks about things that you can have inside complexes, like a university campus has inside it a teaching block or a residential block or something. A wastewater treatment plant has, okay, so let's talk about rail network. Rail network contains a bridge, for example, or a tunnel. Furthermore, if we go to activities, this is what happens inside the entity. So a teaching block has lecturing inside it, but maybe also lighting and heating, okay? If we go to the spaces table, so this is related to the individual rooms or spaces that are bound by the walls. And then we go to elements. So an element is more structural. So we're talking about roofs, walls, tracks, things like that. A system is the other table. So we have a table for elements and then a table for systems. Systems are more MEP, mechanical, electrical, plumbing fixtures, as you can see here in front of you. And products is the lowest level where you have the individual components that you can find in a system or in an element, okay? So these are the usual tables that you would think that you would be using, but let's take a look at the other strange tables that I mentioned. So the CAD table allows you to give a code for individual components inside your model, inside your 3D model. So the title sheet, for example, could have its own code. Your logo, even the blocks themselves that you use or the symbols that you use, the title annotations. Someone might ask, why is this important? I mean, we can understand why each product should be different because of the benefits I mentioned earlier, but why would a title sheet have its own code? Again, this could be useful. Let's suppose that you as a company work with different stakeholders or work with different clients. And for each client, you have a different title sheet that you use. So each time that you use a title sheet, are you going to tell your team today, this time we're going to use the title sheet that has the 5 rows and the block at the top, which is colored in yellow with the Cambria font? You're not going to do that. It's easier if you give that full title sheet a certain code, or sorry, the block, if you give that block a certain code and you just tell your team, we are going to use the block with a certain code, for example. Let's talk about, by the way, I have construction here as with the line in it because we are no longer using that table. That was an original table that was in the tables of the Uniclass, but it has now been removed. And instead of it, we have the tools and equipment table. And again, for tools and equipment, as I mentioned, it contains the temporary works that you can have on site. Form works, plates, beam boxes and things like that, tools and equipment. And again, if they have their own codes, it will be a lot easier to know which ones you are using, which ones you are transferring between different sites, using on repeat projects and things like that. Another table is the form of information. Sorry, just minimizing this thing. So the form of information table actually also gives codes to every single piece of non-graphical communication that you have within the different teams or within the supply chain. A bill of quantity could have, so a certain format of a bill of quantity could have a certain code. A certain template for an invoice could have a certain code. A certain rendition inside 3D or 4D or clash rendition, for example, or a certain visualization method could have its own code. And that is so that you can use these again and again, a certain template, a certain family, okay? A certain survey, a certain certification template or whatever. So all of these can also have their own codes. And my question for you would be to think whether you believe all of these tables could be used in all project stages or not. How effective or how usable you feel you could use them. Mind you, classification codes, which I'm going to show you examples on in a little bit, can actually be written anywhere. They can be put inside a model. They can be put inside a COBie spreadsheet. They can be put inside a database. They can be put inside a normal document, okay? Like, for example, a list of the ones that will be used, which could be part of the mobilization plan in a BEP, or part of a standards, methods, and procedures document within a certain team, okay? So codes can be used anywhere, actually. These are the other two that I wanted to show you. So this is the project management table. As you can see, this is what the codes look like. So the code is alphanumerical. It starts with the name or abbreviation of the name of the table, followed by several numerical codes, which I'll explain later. But as you can see, inside the project management table, you have, for example, the space management requirements, a layout plan, a space design, a survey of some sort, a site survey information. So even if you ask for these things, to make sure that there is no confusion in what is actually being required, the name could sometimes be confusing between different people. So what happens is that sometimes the teams write description of what each of these actually mean and give them codes so that we are very clear on what we are requiring. Same thing for roles. So instead of just saying that we have a chief information officer, a chief information officer could be understood in different ways, maybe by different companies. So it could be an idea to give these roles codes. I am not saying that a lot of people actually use these two tables, but they are available for those who want to. To be honest, the ones that are used the most are the product, system, element, activities, maybe not as much activities, but spaces and entities. All right, and again, it's up to you to decide whether you can use these on all stages of a project or not. I hope I haven't lost anybody so far. I just wanted to show you how the classification actually looks like. So inside the table, when you first open it, you will find, as I mentioned, that you will have a code. So you will have SS, for example, for the systems table, followed by a number, okay? So you will have, for example, SS30, and then there will be SS3010, SS3020, SS3030, 3040, 3050. And underneath the double code, you will find triple code. So under the 3010, you will find 301010, 301020, 30, and so on. And then you will find a quadruple code. So this goes into 4 levels of hierarchy of code within that table, and sometimes even more, as I said. So let's take an example and see what it is. So the SS30 refers to roofs and floors, okay, and paving systems. The SS3010 refers specifically to pitched and arched and domed roofs and floors, okay? If you go one step ahead to 301030, then we are referring to framed, pitched or arched roofs, okay? If you go one step further, then 25 refers to heavy steel framed pitched roofs. Maybe instead of 25, there is a 30, which refers to light steel framed pitched roofs. So as you can see, it is part of a hierarchy within that table for that particular object or that particular system. In that case, we are talking about a system. This is another one, for example. So instead of 30, if we talk about the 50 refers to disposal system. If you go deeper, wastewater disposal system. Primary sewage was wastewater disposal system. And then finally, the lamella tank system, which is used for wastewater, primary sewage wastewater disposal system. So it goes into this depth of hierarchy. And then once you go into the product table, you will find all of the products inside these systems. That's why I am saying sometimes it is important to actually have a merge or a blend between the classification systems. Not all people do that. Some people just give classification system for the system on its own, for the product on its own, but if this is to be used intelligently, especially for FM and OM, sometimes it is useful to have some sort of combining or merging between the product, the system, the space, and the entities, for example, so that you know what that product belongs to within that asset. All right, so I hope I haven't again lost you so far. So this is just showing you how we use them and why it's important to use them and how they look. So who creates them and who uses them? Basically, who creates them depends on what you're actually creating. So the steps of dealing with classification system are as follows. First of all, on a project, the different teams or the different disciplines on a project need to define what are the classification systems that exist in the market in the first place that they can use. And that should happen before creating the BIM execution plan. So as you might expect, this could probably be an exercise that is done between the client, which is the appointing party, as per the ISO 19650 terminology, and the lead appointed parties, which could be the lead consultant, which could be lead designer, which could be lead contractor. So there has to be an identification of what are the classification systems that already exist. And then which ones of these are currently used or have been used by these particular disciplines, these particular people, or these particular companies. It makes it easier if they've used them before. And hence they decide which ones would be the easiest to use and train people on at the moment. Then comes identification of who is responsible, and that would usually be at BEP stage now. So within the BEP stage, after identifying which classification system to use or systems to use, it's important to know who will be responsible for creating those classifications inside the models and the non-graphical documents, and who are responsible for checking them, because it's important to check that they've been created correctly, they've been added where they're needed, and exchange has been happened for them. So all of these, including the milestones of checking and milestones of handover between the stages for those classifications, should be inside the BEP. It could also be inside the Master Information Delivery Plan as well. And it could also be part of the responsibility matrix, which assigns who is responsible for creating what. It could also be part of the RACI or the RACI, however you like to call it, RACI table, which says who is responsible for creating the classifications and who is responsible or accountable for checking them, or who should be informed that they've been done. So actually, this could impact a lot of documents that are part of your project documentation. And of course, then finally, we need to define what is the process of checking them. So what is the quality assurance and quality control checks for these classifications, and where that should be done, when. As I said, who are the authors of them? And finally, and very importantly, how are we going to train our current staff for them? Who is to create the FM and OM manuals to give to the FM OM people, and who is to train those people? This is also very important. So these are the steps that should happen if you are intending to deal with classification systems on your project. On the other hand, if you already have a classification system and you want to move to a new one, or you have started a project without one and you want to embed one later on in the project, then the stages can be similar. So the steps can be similar, but a little bit different. So you should ask yourself, why do you want to implement a classification system now, so late in the project? Or why do you want to change the existing one to the new one? So a list of pros and cons have to be done, okay? So which system needs to be changed? What should it be changed to? When will you do the change? Okay, what are the risks involved in doing the change? Like how much time does it need to do it? What are the costs of doing it and training people for it? And the steps of doing it as well. So you need to have an alignment where you align between the old codes and all of the new codes, and when that is going to happen within the project. So as I said, mapping the old to the new, training again. And lastly, you can also use any automated script to help with doing that change, like using Dynamo or Grasshopper scripts in order to change old codes to the new ones. The most important point, I think, out of all of these is to decide when that will happen within the project and what are the steps of doing it so that it does not disrupt what all of the teams are working on. All right, and again, producing the new manuals for that. Okay, I just want to show you examples of how we can put in a classification code. These are all examples. This is not the only ways. So for example, there's something called a Revit classification tool for Uniclass 2015. As I mentioned before, Revit is an American product which by default uses the Uniclass classification. But there is a tool which you can, or a plugin, which you can basically put inside Revit. And the process is really quite simple. So let's say that you want to classify one of these conduits or whatever this is, an electrical component here. Basically, whilst you're clicked on it, you would, so it's a lighting fixture, you would go to where it says edit type here, and this will open up this table. If you go to the bottom of it, you will find that there are a few areas there where you can actually put the classification. So how do you embed that classification? Very simply, you go to the add-ins tab inside Revit. This is just an example. You may be using other software, and go to where it says assign classification. This will allow you to choose the product that you want from the product table, for example. And once you choose it, it will be assigned so that when you open the type properties again, you will find it inside there, okay? So that's one example where you could put that. You can also do the same for spaces. You can do the same for systems, okay? I'm just choosing a product, as we can see here. Another example is of using classification is inside COBie. If we don't know what COBie is basically something like a spreadsheet, something similar to Excel spreadsheets, which have all of the information about all of the facilities, the floors, the spaces, the zones, the types, the components, the systems inside inside your graphical 3D models. So you can think of it as an asset dump of all of the information related to all of the components in your assets in the form of a table. Because you can add more information here. You can add the vendors, you can add the prices, you can add the characteristics of the individual items. So if you, for example, the COBie, by the way, has a certain template or a certain way that it's written in. And part of it is inside the tab called type, sorry. Inside type, there is a column called category. And this is where we can actually write the Uniclass code of that particular product. This helps us when we create our bills of quantities, because we will know, for example, how many we want to procure from these, where to procure them from, their characteristics, and so on and so forth. This is used a lot in asset management. Okay, so this is an example. Now, I am aware of the time, so I'm just very quickly going to differentiate between what is classification and what is measurement, because I don't want people to get confused between them. Now, a measurement system does not codify or name or classify your object. It tells you ways of measuring your object and dealing with it, okay? It gives you measurement units, measurement rules, rates, and so on. So an example of that, again, a tiny little history lesson here. This is an old measurement system, SMM7. This was produced by the RICS, the Royal Institute of Chartered Surveyors here in the UK. And it was then superseded by the current used measurement system, which is very, very popular, called the NRM, or New Rules of Measurement System. There are 3 NRMs. There is NRM 1, 2, and 3, which were produced consecutively, as you can see, by the RICS organization, and they're used globally. Now, just to give you an idea about what they're used for, they are not either or. They can all be used together. So NRM1 is used more in the stages, the first stages of a life cycle of a project during estimation and cost planning to help you estimate your entire project budget. So measurement systems are used for costing mainly. I should have started with that. Measurement systems are used mainly for costing, not for classifying. They can be used with classification systems, but they are not used instead of classification. So NRM2 is used during the design and construction phases for quantities and work procurements. And NRM3, as you can see, is used during FM and OM. Each of them calculates costs using different methods. So NRM1 relies on the works, for example, substructure, superstructure, finishes. The NRM2 relies on the actual work sections, like are we at the moment doing demolitions, are we doing repairs, are we doing excavations, and so on and so forth. And NRM3 for the FM and OM relies on measuring per unit, okay? I'm just trying to quickly go through this. A quick introduction of NRM2, which is the most used out of all of the NRMs. It is mainly used to create bills of quantities, and it even tells you what are the sections of bills of quantities that you should have, producing schedules of rates and so on. So inside NRM2, there are 3 sections: a general one at the beginning, detailed rules, and then tables, which are even more detailed. So this is an example of part 1 in NRM. It shows you all the categories that you can measure and cost. So if we take the decoration one, which is 29 here, this is what it looks like in part 2. It tells you that you should have plans and elevations, you should have painting and decorating schedules. So it tells you what you should do. And then in part 3, it tells you how you do it. So it tells you what the measurement units are for it, what are the levels, how do you actually measure those levels, and so on and so forth. Again, all about costing. And NRM2 also tells you that you should have one of 2 types of bills of quantities, either firm for lump sum or approximate. And it also tells you that you should have 10 sections for your bills of quantities. I will just leave it at that for now. You can go and download it yourself and see it. The final thing which I want to show you before we move on, I have mentioned that this is used for costing. I want to give you an idea about my own project in just a few minutes that are remaining. As I mentioned before, classification talks about products and how they relate to systems, spaces, activities, entities, and complexes. But in heritage, there is more than that. In heritage, there is the architectural style, the geometric ratio, the construction method, cultural value, the condition of the part, and many, many more characteristics. This is why the project that I was doing, which is a collaboration as part of the institutional links with the British Council between UK and Egypt, we were creating a new classification system specifically for heritage, which we did, and we are currently embedding or joining with Uniclass as part of my work with the MBS right now, and as part of working on the Westminster Palace. So we were working on this project here, Tosun Palace in Cairo, which is a Baroque Renaissance palace. These are all examples of all of the components within it. Of course, we did scanning, complete 3D scanning, 3D modeling, and we identified problems. We tried to do our own classification system for it. And we created a new ontological classification classes. These are a summary of them in front of you. I would be happy to share more information. We have many publications about them as well. And what I want you to look at is this list. These are some of the extra things that we identified that should be included in a classification system for heritage, which do not exist nowadays in a classification system. Furthermore, we identified that there should be relationships between them which change. So there should not just they should exist, but relationships between them. And this is the final classification system that we produced. I just wanted to show it to you, but I'd be happy to give more information about that. And that basically wraps up what I wanted to show you today. I know it's a lot maybe to take in, but I hope that there's a kind of indication of what is classification, why we need it, the different classification systems, how they are different from measurement systems, how we might see them inside projects, and a little bit about my own project. So wow. I'll stop talking now.
Wow, Doctor, thank you so much for that beautiful presentation. We have really learned a lot. And in this last 5 minutes, Doctor, we would kindly want the audience to push in as at least 2 questions, quick questions.
I am happy to stay on a little bit more than 5 minutes if the audience would like to. So
thank you so much. Please, anyway, we have Sidha Ahmed asked a question and said that, does changing the system require a CDE migration?
It does not require, if you mean changing the common data environment itself, no, you do not. Because the classification system is not per se part of your access rights and part of your divisions inside your CDE. But if it is part, like for example, if you're using a CDE like for projects, for example, which creates the classification system inside the COBie inside it, then you would need to find a way to migrate that to a new CDE if you want to. But if you are just changing the Uniclass, you do not need to change the CDE itself.
Wow, thank you so much, Doctor. I hope Mr. Sid Ahmed has been answered. And we have a question from Chue Sam. He's saying that, is there any relationship between classification and NRM?
Yes. So what people do is that they take the components that they are trying to measure, they measure them using the rules inside NRM, but they refer to them using the classification code inside the classification system. So instead of writing, for example, stucco plastering, they would use a classification code for it and then use the measurement method inside NRM to deal with that particular component. This is how you marry the two together. And that would be something that you would probably write inside your documents. So as part of your tables inside the mobilization plan, for example.
Thank you so much, Doctor. I hope Mr. Sam has been answered. Now, Sileshi Tesema is asking that, what is the similarity between the different classification systems we have now globally, such as Uniclass UK, Omniclass USA, Chuneco Denmark, CoClass Sweden? Why do we need to have different classifications? It is rather better to have one standardized classification.
Well, of course, it is better to do that, but you cannot prevent every single country from having its own used classification system that they are comfortable with their local manufacturers. Mind you that classification systems are very related to manufacturing. So each country has its own method of doing construction. We cannot say that they're all the same, and hence rules are different. It would be great to have an ISO standard that unifies all of these together, but unless that happens, we're stuck with trying to map between them as much as we can. The MBS toolkit, the online toolkit, actually maps between Omniclass and Uniclass, and I think a few others as well. You can take a look at that if you want.
Oh, thank you so much, Doctor. I think because of time, we are going to post the session on our YouTube channel, that is BIM Africa. And we would like to thank everyone. First of all, we would like to thank you, Doctor, for sparing time to help us with this immeasurable knowledge that we have received today. Thank you so much. And great thanks to everyone that has joined us today for the very first session of BIM Africa Talk 2020. And I would like to inform you that we shall be having this particular session, this similar session in February, and we would be letting you know across all our entire platforms. Thank you so much for tuning in. Thank you so much for joining. And please let everyone know what kind of knowledge we're receiving here. We would like to thank everyone. Would like to thank the team at BIM Africa and everyone that has been able to participate in this meeting. Thank you.
Thank you, everybody. I am happy to take questions on my email address in front of you here if anyone would like to. Thank you.
Wow. Thank you so much. Thank you so much, everyone. Have a great night.
Have a great evening. Thank you.
Hey,